What I'm basically going to be going over is how to use Spark. Spark, in a nutshell, is a very, very commonly used uh, framework or engine, depending on how you use it, in big data. So a lot of companies kind of process their data using Spark, and we're gonna go over kind of what Spark is, some of the issues with traditional forms of data processing that it kind of helped fix, and yeah, so let's get into it. And just a check, can everyone hear me okay? Yeah. Okay. Let me know if you can't. Okay. Don't know if this is, oops. Sorry, just, okay, perfect. So my name is Palvisha. I did my first degree in physics at York, and after graduating, I started working as a data engineer. So I have a little bit over 2 years of experience working as a data engineer, and I've worked in my previous role in industries such as finance, insurance, and currently I work in healthcare. Okay, so today, what we're going to go over is just, well, my introduction and agenda. We're going to cover a small history of big data, how distributed clusters kind of work, kind of like an overarching view, and then we're going to spend some time setting up our environments, talk about Spark, and then get right into the demo. Does that sound good to everyone? Okay, perfect. And then, yeah, we'll obviously have time at the end for any Q&A, or if you guys want to ask any questions about stuff in big data in general. So getting into big data. So back in the day, before Spark was ever a thing, the way that data was traditionally processed was on premises. So we didn't have cloud, right? So a lot of these companies would pretty much control exactly how they process their data, and they would have to do it with physical machines on premises. The issue with that, however, was that there was a lot of data, but there was no actual like efficient way to process it. There was no standardization because companies decided how they wanted to process the data. And this posed challenges such as scaling because since there was no, since you had to get physical machines, those were expensive. It was a lot more expensive to actually horizontally scale. And so cost was scaling and cost go hand in hand. Those were some pitfalls with how data was processed back in the day. And there was also a level of inflexibility. So when you tried to process data, you would effectively have to purchase data processing solutions from specific vendors. And if you selected a specific vendor, you would be tied to that vendor. So the machines that you got would have to be machines that that vendor used. So as an example, if IBM provided data processing software and you decided to go with their processing software, you would have to get IBM machines. So you were effectively vendor locked. If there's some sort of data that the solution didn't process, you would be basically stuck in the kind of data you had processing abilities for. So not a very good flexible way to process anything. And of course, it was there was low efficiency. It wasn't very efficient. Data processing was a lot slower than it is today. So that resulted in slower decision making and business insights. Okay. So in a nutshell, storing and processing large amounts of data was previously really tedious and expensive. But then we have this concept of distributed clusters. So this kind of, like I'm going to introduce distributed clusters first because it's important to understand what they are when we start talking about Spark. Um, So distributed clusters, does anyone like, I guess just from your own knowledge, know what a distributed cluster is or how it works? Mhm. Yeah, exactly. So effectively what you're doing is you're taking one processing load and you're splitting it amongst different computers so that you can process multiple amounts of data at the same time. So this pretty much like a good way to kind of understand this is the grocery store analogy. So imagine you only have four cash registers and only one of the four is actually open. All of these people that are waiting in line to have their items scanned and checked through are going to be standing there for a really long time because there's only one cash register and there's only so much that one person can do at a time. But if we open up two cash registers, you can split the amount of people between the two cash registers. Now you have half the amount of people that need to go through each register. And both registers are working at the same time, so it's a lot more efficient. Add another cash register and it's even better. Now you have a third of the people at each register that have to get processed. And again, now you have a fourth once you open up another register. So this is kind of how a distributed cluster also works. You are pretty much taking a large amount of data, you're distributing it over multiple nodes in a distributed cluster, and then each node is responsible for processing the data within itself. And the one thing that's not here is something called a resource manager. So in our grocery store analogy, our resource manager would be like the boss. The boss decides, who's at what register, how many, like, I guess, like how much time each person spends at each register and so on. So, like the boss in this case would be kind of like your resource manager for a distributed cluster, which essentially dictates how many resources each node in your distributed cluster gets. And depending on how many resources it has, it might be more or less efficient at processing data. Does anyone have any questions so far? Don't know if I'm going too fast. Let me know if I am. Okay. So in a nutshell, a distributed system is pretty much a combination of different machines that are all connected and work together to process data. Each machine in your cluster is called a node. These nodes also contain distinct nodes within them. You don't have to worry about that too much at the moment. But essentially what that just means is that once you have a computer, that specific computer is your node, and then within that computer you have cores, you have like cores and stuff to process data, so you can actually um, uh, basically manage those specific nodes within that computer as well. And then, some nodes are there to partition data. So again, like the different tasks that you have might be assigned to different nodes. Some of them partition the data and distribute it over the cluster. And then some of them don't process or store the data. They actually facilitate memory and resource management. So different nodes have different roles. And the data processing role, you tend to have more nodes that process and store data than you have nodes that actually do resource management because you need more processing power. Okay. So before we get into Spark, I think it's a good time to just make sure everyone can get their environment set up. So Um, if you go to the hack pack, you should be able to see, and let me just also uh decide, you should be able to see some workshop resources. You'll see a link to the workshop data, and then you'll see a link to the workshop repository. Does everyone have access to these? Yeah. Okay, so for the workshop data, let's start with that. So the data that we're going to be working with today is tardigrade data. So if you can basically download this and then store it in your My Drive location. So just like the top level Google Drive location that you have. I'll give everyone like a minute to do that. Is everyone good with this? Do you guys need help finding the data? Give a couple more minutes. Okay. How's everyone with just like finding and storing the data so far? It should just be pretty much like where mine is stored. It should just be in your like top level My Drive location. The My Drive and then the data. Oh, yep. Oh, do you guys have the hack pack for this workshop? It should be linked to the hack. You found it? Okay, I guess I'll give everyone a couple more minutes. Okay, everyone good to go on? All right, so once you have the data, just again, make sure it's in this the same format as mine. And then if we go back to the hack pack, there should also be a link to the workshop repository. So you should be able to, you'll see something like this. It's just one branch. You should be able to just clone the repository. Or actually, you don't even have to do that. If you go into the actual .ipynb file for the Colab notebook, there's a button on the top that says Open in Colab. So you should be able to click on that and it should take you to the actual workshop. Um, yeah, so is everyone good with that? Let me know if you guys are having trouble with getting to the notebook. Give everyone a couple minutes for that too. Okay. Is everyone good with the notebook? Okay, cool. Let me know if you guys are having any issues with the setup. So let's go through setting up our notebook first. I just want to run the first couple cells so that we can make sure everyone can mount their data drive and also install the dependencies that we need. So what we're going to do first in the first cell is we're going to install all of our dependencies. So one of those dependencies is Java. Spark is coded in Java and requires JVM wrappers to function properly. So this is why we're going to install Java into our Google Colab environment. And the next thing we want to do after that is install PySpark, since we're going to be working with Python. So can everyone just run the first cell and let me know if you run into any issues? Should hopefully not run into anything. Everyone good with that? Maybe, okay, cool. You can see it just, installing everything here. About a second to go ahead. Okay, now it's downloading PySpark. Is everyone else able to install everything okay? Okay, perfect. And then the one other thing after this that we want to just do is make sure our imports are all working fine. So I'm just going to give it a couple minutes to finish what it's doing. Okay, perfect. So everything is installed, and after that, just run the cell at the bottom to import PySpark and all of the PySpark SQL types that we would be using, and let me know if that works. It shouldn't take as long as the first cell. Is everyone good so far? Okay. And we're gonna skip initializing a Spark session because I want to talk through that. Going to jump down to the second section and just connect to our data storage location. So if you have set up everything the same way as I have, this should work for you right off the bat. If there are any issues, do let me know. But just hit play, it'll ask you, hey, do you want to connect to Google Drive? So connect, and yeah, authorize that, and you should be good to go. Going to finish mounting the drive. So what this will do is it'll mount our Google Colab environment to the root level of Google Drive, where we can access all of our other data. Okay. Did anyone run into any issues with any of these steps? Okay. If you've joined late and need some time to get set up and run into any issues, do let me know. But if everyone's good, can continue talking about Spark now. So we've talked about all of the different issues that we've had with processing data back in the day with on-premise computers. We've talked about what distributed clusters are, and now we're going to introduce Spark. So Spark is a framework or an engine depending on how you use it. So usually it's defined as an engine because it comes basically completely packaged with out-of-the-box functionality to process data. You don't have to build that functionality yourself. You just have to use the functions it already has available to do the processing that you need. Um, but there are tools that are built on top of Spark. For example, Databricks is built on top of Spark. So, well, in that case, Spark would act more like more like a framework rather than an engine. But Spark is very, very cool. So one thing that it got rid of was the cost. It's open source, which is why so many companies use it. It uses the whole concept of distributed clusters. So you basically distribute tasks over a cluster of computers in Spark, which makes it efficient at processing large amounts of data. And it has support for Java, Python, R, and Scala. So this was the other thing. Back in the day, you can only write your actual functions to process data in a very specific language that not many people would actually know. So having support for all of these languages means that you can choose whatever language you're most comfortable with, which in our case is going to be Python today, um, and use Spark within that language. It has support for different resource managers. So back when I was talking about distributed clusters, I mentioned that you have resource managers as part of your cluster to distribute resources and manage how the cluster is basically working. There is another technology called Hadoop, which is also open source, and it works with a distributed cluster as well. It's also a big data technology, but Hadoop only supports Yarn, which literally stands for yet another resource manager. And that's the only resource manager it supports. Spark can support a variety of different resource managers. And it contains, like I said, out-of-the-box data functionality, so you don't have to actually write your data processing functions, and that reduces redundancy. So where this would kind of fit in your whole like pipeline, this is a very simplified diagram of it, but effectively what you have is you have like your data source, whatever you choose, wherever you choose to store your data source, you're retrieving data from your data source into your application, and your application contains Spark code, which then takes that data and all of the processing that has to happen with it in that application and distributes the actual tasks within that application over a distributed cluster. So these are basically just distinct computers that take all of the processing tasks that you would have defined in your actual code and then just has them actually process on the cluster of computers. And that cluster is actually called a Spark cluster. So in a nutshell, Spark is effectively an engine that addresses many of the issues with like processing data back in the day, and it is language agnostic, very easy to use. Any questions about kind of Spark so far? Okay, just as a question, has anyone here actually used Spark before? No? Okay. Well, I will tell you this, it is much faster than processing data in pandas. You still work with data frames, but because, well, Python, for example, doesn't have parallelism, right? So because Spark allows stuff to happen over a distributed cluster, it would actually allow data to get processed a lot faster than Python native libraries like pandas. So as an example, I did a thesis project last year and one of my teammates wrote like code to process about 100,000 lines of like financial data. It took almost 30 minutes for that code to run. So I rewrote it in Spark and it did it in less than a minute. So, oh yeah, question?
Just a question. Uh,
Even on your local, I was running locally and because it would work locally too.
oh,
Because it will be effectively, so for us in Colab right now, it's a great question. It's we only have a single node that Colab works on. So what we would have, all we have available for us are the actual resources within Colab, Colab node. But on your computer, you have different like cores, so it will actually distribute the tasks over the nodes within your actual computer too.
okay, so you will create like some independent little.
Yeah, exactly. It'll distribute it over the resources within your actual computer. And the other cool thing about Spark is that it actually works in memory rather than on disk, so it's a lot faster at retrieving and processing data than uh, other like alternatives. So yeah, that still actually holds even if you're running like Python, like Pandas native code versus like Spark code locally, it will still be faster. Yep. Yeah, if you're running locally, it's limited by your own device. But you can also set up a cluster of computers, like you can set up a cloud like cluster and basically run Spark applications on the cloud. And that would be even more, I guess, scalable and efficient, right? Yeah, exactly. Yeah, you'll commonly see it used with like AWS EMR. You'll see it used with Dataproc. I've used it with both, currently using it with EMR. You'll also actually see it used with Hadoop's distributed file storage system too, which is also another way of producing a cluster. So yeah, there's like the world is effectively your oyster with what you choose, which is another thing about Spark, right? It actually doesn't keep you vendor locked. You can pick and choose what you want to do with it. Any other questions? Okay, can't seem to find my. Oh, oh, sorry. I think my mouse just decided to connect to my iPad. Okay. Okay. So I guess this is a nice leeway into us actually setting up our first Spark application. So let's go back to the actual notebook. Okay, so we should have, if everyone was able to set up everything good, we should have our dependencies all installed. So we should have Java and PySpark installed. We're just setting the Java home. So Java was installed in our Google Colab environment. We're just effectively just pointing to that. Um, and that should have worked, as well as the imports for the Spark functionality that we're going to use. Okay, so the first thing that we're going to do here is we're actually going to initialize a Spark session. Okay, so what this is doing is it's creating this like variable called Spark, which is effectively our Spark session. And Spark session is something that we've imported from the from PySpark essentially. You're setting the app name, and then you're pretty much just calling it the get or create to either grab an existing session or create a new one. And you can see that there's no other parameters set, so it'll just use any default settings. You go ahead and run that. That will initialize our Spark session. So what this is going to do is it's going to initialize basically the session in which we're actually going to be able to run a Spark job. And once that job or our application is complete, we'll have to close the Spark session, essentially. Okay. So hopefully everyone was able to connect to the Google storage location or the data storage location properly and mount the Google Colab or mount Google Colab to Google Drive. So now what we have here is a schema that I've defined. So if we go back to our data, there are three sets of data on tardigrades. We have their location, we have their occurrences, and we have their taxonomy, which is more so just their scientific information. So what I have over here is basically just the schema for the taxonomy data. And the reason that you don't have to explicitly define a Spark schema, like a schema to read in data. Spark can infer schemas on its own when you read in data. The reason that I have done this is because it reduces the chance, it's basically a validation step in a way. It reduces the chance of the wrong data type being found in the wrong column. So because Spark is inferring schema, if you didn't do this, Spark would effectively be inferring schemas. So it might not do like a precise job of explicitly, for example, setting species as a string. Maybe there's like a number in there that it also grabs as well and doesn't error on. This will allow you to basically catch any issues with data types in your columns. So I've explicitly defined the taxonomy schema. What I'd like you guys to try is to, you know what, I completely named this wrong, so this should be taxonomy. I want you guys to try this for the occurrences. So same thing as what is over here for the taxonomy, but for the occurrences. So I'll give you guys a couple minutes to look at the data and kind of set up what you want for the schema. After that, we'll actually go through it together too, but I'm just gonna give you guys some time to figure it out too. Yep.
Also, basically, like, I remember you mentioned some things in terms of the naming for the first variable or something. Is the first one occurrence or taxonomy?
Oh, it should be taxonomy, sorry. Yeah. Sorry, this should say taxonomy. Everyone else good so far? Any questions? Give you guys like 2 more minutes and then we'll start typing out some stuff. All right, so for my tardigrade occurrences, I'm going to just call it occurrences, schema. And the way I want this defined, so if I go back to the data, this is a bit inefficient, but I have all of these columns pretty much that I want my data to have. So I am just going to pretty much do exactly what I have above. So I'm going to copy the structure type, which defines basically my schema. And I'm just going to change some stuff here. So what I want for the occurrences is I have the GBIF ID. Instead of individual, I basically have the country code for where that specific record was found or the occurrence of the tardigrade was determined. I have the locality. So far it's all strings. Everything that I want here so far needs to be a string. I have the state province. And I have the latitude and longitude. Decimal latitude and the decimal longitude. Okay. I can take all of this out, and that is my occurrence schema. Oh, oh, right, sorry, I think I have it in the wrong spot. Oh, right there. Thank you for catching that. So let's just put that in the locations, and then I call this location schema, and then occurrences will actually just be pretty much the same thing. And then I want to have the dataset key. Okay, I'm going to read that in as a string for now. If I want to change it into an integer after, I can. Occurrence ID. Um, the individual count, the publishing organization key, event date. Copy a couple more of these down. Okay. Uh, Event date, I want the day for that actual occurrence, the month, the year for when that was recorded, and the basis of record. Okay, that should be everything that is in my occurrences dataset. So we have the location, we have the occurrence, and we have the taxonomy schemas defined. So we can go ahead and pretty much just set those by playing that cell. And now those are set. So we are actually ready to read in our data. So what I've done here is I'm importing OS so I can actually access the current environment. And I am trying to list all of the contents within the drive that I've mounted to Google Colab, or this instance of Google Colab. So if you run that, it'll tell you everything that's spread in. I am going to go ahead and I pretty much know exactly where this is, but if you run that, it should tell you exactly where your data is located. And then you can go ahead and basically uncomment the first line where we're reading in the taxonomy data. Make sure that you're setting the rest of this path according to what you've found after running this, and set header to be true. I'll just give you guys a minute to do that, and then I'll explain what's happening here. Is everyone good with finding where their data is located? The root should hopefully be the same as me if you've put like everything, all of your data in the same location. If it's not, you can always change your root directory. So what this is doing is it's reading in a CSV file. So from Spark, we're calling the read function, and the format that we're using is CSV. We're giving it the path to read from. And then with us setting header equals to true, well, since it's a CSV file, it'll have its own, like it'll have one row where it actually has the real column names, but then it would have its own columns defined by the CSV format as well. So when I set header to be true, what it does is, so as an example, like here, column one is, or sorry, row one is all of my columns. Instead of having like column 0, column 1, column 2, it'll actually pick my first row as the column names that I want, if that makes sense. Was that confusing to anyone? Sense? So it pretty much like avoids picking up like the lettering at the top, and goes straight for row 1 to pick up that as the column names. Okay, so if you do that, it should read in the data uh, pretty easily. I think we don't have too much to go through, but okay. So as you can see, at the bottom here is a chance for you guys to also read in the occurrence and the location data sets pretty much the same way. So I'll give you guys a minute to do that on your own, and then we'll type it out ourselves. So you should have something, if you've followed exactly what was here, you would pretty much have this exact same thing with a different name. So instead of tardigrade taxonomy, it would just be occurrences. Okay. Which is also somehow spelled wrong. But moving on. Same thing here, you would have that, but location instead. So here you'll probably be wondering why we defined a schema above. We can actually do this exact same thing. So if we have it set up like this, what is going to happen is that Spark will infer the schema on its own, but we can actually add in a schema property. So if we just set schema equals, and for our taxonomy, we obviously want the taxonomy schema. It will now read in all of the data explicitly with that schema. So if there's any issues, it will pretty much catch it at this point. And we can do the same thing with the occurrences and the location. I think it, I remember I called it something up here. I'm gonna just copy this in and set that. Oops, here. And same thing with my location. Okay, so now that I have that, I'm just gonna read in everything again, and you will see that, oh, it is not finding my data for some reason. Okay, let me just copy that. Okay. Okay. Perfect. So now it's not erroring. That means all of my files actually match the schemas that I've defined. No data type is out of place, and it's able to access and read in all of my data. So if just as a check, if you want to make sure it like actually ran, you can uncomment the last line and rerun the cell, and it should output that all data has been read. Is everyone good so far? Okay. Now, these are three different data sets. On their own, they might be useful, but they would provide more insight if we can actually create a larger data set using them, which is exactly what we're going to do. So I took all of the schemas and I have defined a larger schema. Now, you've already done this for each individual data set first, so you don't actually have to do this again, but I like to do this just as a fail-safe check to make sure nothing goes wrong. But this isn't really a necessary step. It's just a nice to have. So I pretty much just combined all of these schemas above here into one large schema for my brand new data set, so I can actually explicitly type the new data set that I would be creating. Okay, so I am gonna go ahead and just run that. Gonna make sure. Okay, should be good. If this error is out, it's probably due to some code we need to finish at the bottom. All right, perfect. That is fine. So it didn't error here. We have our schema set up. Now what we're going to do is we want to determine a primary key for the new data set, right? We want to combine all of these data sets into one. So what I'm going to do is I'm actually going to remove also this duplicate. And okay. So what I want to do now is pretty much just determine what my primary key is, or what like key I'm going to join the three data sets on. So the constraints to having a primary key, you need to have something that is unique and not repeated, and a column that pretty much every single data set actually has. So in our case, the one column that every single data set had was the GBIF ID, which is just the database ID. So all I want to do is confirm that that ID is unique. So what I'm doing here is I am just going to find the total count or my total number of records, and then I'm going to find the count for my actual specific column. Okay, so to do that, what I'm going to do is I'm going to take my data frame that I've chosen to kind of do this arbitrary count on, because all of the records, there should be the same number of records in each. I'm going to take that data set. I'm going to select the column that I want. And again, this is like some of that out of the box functionality that Spark has. So I'm going to select the column using the column name. So that's the GBIF ID. And then I'm going to make sure that everything is pretty much, so I'm going to just take this and I'm going to count that. Okay. So what this is going to do is it's going to count, oh, and I want to do a distinct as well. So what this is going to do is it's going to count the actual distinct actual distinct IDs that show up. If the number of distinct IDs that show up matches the total number of records, that means each record has its own ID and we can use that as our primary key. Okay, and this here will let us know if it can be a primary key or not, just as a little check to see if everything has worked. Okay, and I'm just going to comment this out so it doesn't error for us. Oh, and where is it complaining? Ah, sorry. For distinct, it's also a function, so you have to make sure that it is called with the two brackets. Otherwise, it will error the way it errored for me right now. And that should run perfect. And we can see that it does in fact have the same count, so that ID can be our primary key. Now all we have to do is go ahead and join the data sets together. So I'm just going to call it my tardigrade data frame. I'm taking my occurrence data frame and I'm joining it with the taxonomy data frame on the GBIF ID, and I'm doing an inner join. So where it says other data set, you can go ahead and do the exact same thing with the location data set. So you would just have your location DF. I'm also going to join that on the GBIF ID, and I want to do an inner join. I don't want anything that doesn't match. So an inner join ensures that everything, all like records on both sides have the exact same ID. Otherwise, it won't add it to the join. And we can also comment out this last line here. You kind of see what we get after the join. Okay, so it's joined, now it just needs a minute to read everything out. So I'm just showing the first 5 lines of the data, and that's pretty much what it does. So you give it your data frame name, you call .show. First you can put in a number. So the number is just the number of records you want to see, and what false does is if you set the second parameter to false, it will either expand or constrict your data columns. So when I have false, it basically expands it out so I can see everything that's in this actual column instead of cutting stuff out. And guess the last thing here is just to do some null checks. So for our actual validation, you always want to validate your data. You can do null checks by doing something like what I have in line 15. So in the interest of time, um, I will just go through this really quickly, but you pretty much just want to check the counts for any nulls that you might find. So you pick out columns that you don't want to have null. So I don't want any IDs that are null. I don't want the species to be null. Some other stuff that I've said I don't want null is the dataset key. So I don't want the dataset key to be null. So I'm gonna, in here, add that in and just say, I just want to find if it's null or not. So I'm gonna set that. I'm gonna basically filter out for anything that is null. One of the other keys that I want is the country code. I don't want that to be null. And I think, oh, and I don't want the species key to be null either. So I'm just going to add that in. So what I'm doing here is I'm filtering for everything that from those columns that is null, and then finding the count. If any of those columns have a null value, I'll have a count greater than 0. But what I want is my count to be 0. So I'm just filtering for anything that's null, checking the count. And so now that I have that, I can just print my count as usual, as you would in PySpark or Python in general, and boom, I get 0 as my count. So nothing in my data set is actually null. Okay, everyone good so far? I know I've kind of rushed through the last couple cells, but good so far? Mm-hmm. Mm-hmm.
Point like say there are duplicate.
So that's a great question. So usually you don't want to drop data. You would want to look at those two records and see what's going on with the columns in those records. If they're the exact same record, then you're okay to drop one of them. You don't need to keep it. But if they're not the exact same record, then it depends on kind of what you want to do. You can either populate the rest of the like the values that might be like missing in one of the records by just looking at trends in the rest of the columns and then change the ID. Or you can combine those two records into one.
So we'll call like missing.
Missing record. So like, are you saying like it's like the row is completely missing?
Like,
Mhm.
still able to
Um,
just in one row.
So one row, so even so with missing data, if it doesn't exist, it'll just set that yeah, it would set those to null. But you can also, if you don't want null data, the best way usually to fill out those columns is to look for trends in other like the rest of that column. So let's say country code is like missing and it's a categorical variable, you would want to use the mode to determine what might be the most likely location
So
to fill it in. So you can determine what the mode and stuff is. You can do like do calculations like that, and yeah, you can insert as well, pretty much. So you are able to pretty much just take your actual. You can filter for your actual record by the key, and then just set its column to whatever, like that one column to whatever value you want. Is also doable. So yeah, it's pretty versatile. It's really easy to use, in my opinion. Um, Okay, so this last step here was actually, so I know we've pretty much ran out of time, but what this was going to do was we were going to stop our current Spark session. What this would do is pretty much like end everything, all like pretty much end our entire Spark application, stop us from doing what we were doing. And then we were going to set parameters for that for a new Spark session. So you can do a lot of Spark tuning. You can, as an example, set the executor memory. This basically assigns memory to each of the actual like cores that are doing the data processing, which is what an executor is. You can also set other parameters like how many partitions of data you want, or things like how much memory you want the master node to have, and things like that. So that was what this was for. We have ran out of time, but what I will like let you guys do is if you want to stick around and ask any questions, I'll go ahead and I can show you how to do this. Or you can also like look into like the Spark documentation and different types of parameters that you can set and try this out. Um, but yeah, does anyone have any questions about anything we've went over today? Nope. Okay. Cool. So I guess that concludes our workshop. And thank you all for coming. I'll still be here if you guys have any questions about Spark or just like big data in general. Cool. Thank you guys.